Thank you for attending this session. Uh, like Gavastar explained on the introduction, my name is Dennes Torres. I'm a data platform MVP. I live in Malta. I'm Brazilian, living in Malta, Europe. So let's talk about real-time data using string analytics in Power BI. This is a short slide about me. You can take a print screen and connect. It will be a pleasure to keep in touch on social media. It will be a pleasure. So, the agenda for this session, we'll talk about real-time dashboards, the process of ingesting data, string analytics, streaming datasets, and Power BI user interface. Some details about the Power BI user interface. So I would start with a demo about real-time dashboards. But first I need to alert that I make most of the demonstrations live, but some of the demonstrations will not be possible to make live. Unfortunately, I discovered this today. This is an old set of demonstrations that I already did many times, but they depend on this URL that you are seeing on my screen, streammeetup.com. It's a streaming provided by Meetup, which shows real-time Meetup data about RSVPs to Meetup events and so on. The problem is, for some reason, Meetup changed this URL. This URL is not live anymore. So Meetup changed the URL, unfortunately. So I will show many of the building demonstrations live, but when I need to show some executing demonstrations, I need to show a video recording. Unfortunately, is let's say my backup plan for this. Let me show you a small recording of a demonstration showing the string working. You may be seeing the recording on my screen. Let me leave it running a bit. Okay, the intention here was to show the numbers changing. You see, the numbers were changing in real time. That's the intention. The end result that you get is a real-time dashboard showing the numbers changing in real time. It's very important to highlight how real-time dashboard is different than the real-time report. They are two different things. Power BI has the concept of dashboard and has the concept of report. In this example here, I have a report and I have dashboards. The dashboards, they work in real time automatically. So we build an object which is called a streaming data set. And the dashboard shows the data in real time automatically. But a report doesn't. A report doesn't work in real time automatically. And using the streaming data sets together, stream analytics, which is what I will show today, real-time reports would do not work together, this technology. The both technologies don't match. I will talk more about this. So to see the data really in real time, see the data changing and see the data at the moment, we need to see the data in a dashboard. If we try to see the data in a report, we need to keep refreshing the report all the time. We need to stay refreshing the report all the time. So let me get back to the slides and explain more about how this works, how this technology works, how do we put the pieces together to make this work. So, ingestion process. Well, what is this ingestion process? We're talking about real-time data. So the amount of data which arrives from, let's say, a production environment is huge. So we don't even say that we are importing data from the production environment, because the amount of data usually is very huge. So we call this import in real time an ingestion process. And there is an architecture that we use for this. This architecture is called Lambda architecture. So we'll use the Lambda architecture to ingest data in real time. What's the idea of the Lambda architecture? The main idea of the Lambda architecture is to have a tool which is responsible for receiving the data. Being responsible for receiving the data, this tool is a tool capable to deal with a huge amount of data. So this tool needs to be capable to deal with a huge amount of data and then let this data be available for a small period of time to be queried by other technologies. So we have an ingestion point. This point will receive, this technology will receive the data. And using Azure, because we need to use Azure together Power BI to complete this architecture, this technology is the Event Hub. We use the Event Hub for that. That's great. And then after the Event Hub work to receive the data, this architecture uses two different layers. One layer called speed layer and another layer called batch layer. What's the idea and the difference? The idea of the speed layer is to be able to show what is happening in production in real time. The idea is to show you the data which is arriving. Make some aggregation, show you a summary of the data. It's not the idea to show you the detail of the data which is arriving in real time. The idea is to show some specific aggregations, specific numbers, and show that these numbers are arriving in real time. And you can even create some automations to work on these numbers, work over these numbers. For some example, a specific number, if it changes drastically, it has a huge change from one moment to another, you may need to take some action. So you can even automate some action in relation to this. So the idea of the speed layer is to provide information about what's happening in the moment. And it's not the idea to show the details of the record. So we use another Azure feature, another Azure Tech Service technology called String Analytics. The String Analytics is capable to get the input, like the input from Event Hub, process this input, creating aggregations, and creating these aggregations, we're talking about real-time data. So we need to manage the time on these aggregations. Would we like to aggregate each 10 minutes of data? Would you like to aggregate even each 5 minutes of data? So which time windows we would like to aggregate? So string analytics is specific for this kind of task. After executing the aggregation, string analytics send the result aggregated to a consuming layer, a consuming technology which will show the results. Sorry. In this example, it's here where it comes Power BI. Power BI is a consuming technology which will get the results, the aggregated results from the speed layer, showing the information in real time. The other layer, the batch layer, is intended to really save the data and allows some historical analysis over the data. The data generated by the speed layer is intended to be displayed and discarded, but on garbage. We will not use this data anymore. If we need to make some historical analysis with the data, we use the batch layer to make historical analysis on the data. Usually, we use here an Azure storage account. And he is suggesting all the possible technologies which could be used on the batch layer. Azure Data Factory for transformations over the storage. Azure Cosmos DB is a possible replacement for the storage. So these are some possible technologies used as a batch layer. The important point is that the batch layer is a historical set of data, while the speed layer is a real-time set of data. And Power BI can work as a serving layer for both. Not exactly on the same report or dashboard, of course. We can create real-time reports for the speed layer, and we can create historical reports for the batch layer. We can create reports for each kind of layer using Power BI. Power BI can work with both. Then, on this session, of course, we'll focus on the speed layer. Our focus is the speed layer on this session. And there are many public streaming APIs, which provide streaming information in a public way. For example, there are public APIs providing transport information, especially on Europe, information about public transport. Meetup has or had the streaming API. Today, the Meetup streaming address is not working. Twitter has a streaming API, and there are more. Many public streaming APIs which we can use to make examples of real-time data consumption. And the Event Hub, how the Event Hub works. The Event Hub is the first element in an ingestion architecture. It's the guy who will receive the data, control the receivement of the events, the arrival of the events, and forward the events for the consumers. In our example, the consumer will be the string analytics in the speed layer. So string analytics will consume the events arriving to Event Hub and can forward to multiple places. Event Hub can forward the events to multiple places, to the speed layer and to a storage account, for example. So you can have multiple destinations, multiple clients within the information from Event Hub. Exactly like we need on the Lambda architecture. What Event Hub doesn't do, it doesn't go after the streaming. One application needs to insert the streaming on Event Hub. Event Hub doesn't go after the streaming. For example, I just mentioned that there are many public streaming APIs. for transport information, for meetup information, for Twitter information, many public streaming APIs. But Event Hub can't go to them to get that. So we need something to read these public APIs and insert the data from these public APIs on Event Hub. So how do we tie existing streamings with Event Hub? For example, Transport API, Meetup API, Twitter API. How do we make these public streaming sources arrive to Event Hub? So we need an application, one application, that which will read the streaming generated by these public APIs, and we'll write this streaming to Event Hub. On Event Hub, when we are provisioning the Event Hub on Azure, we create an Event Hub namespace, and then we can create many Event Hubs inside an Event Hub namespace. And you can have one Event Hub for the transport information, for the meetup information, for another for the Twitter information, so one for each streaming. And applications reading the source streaming and sending the data to Event Hub. So we need, what's important on this point about what we are talking about, is that we need an application to insert the data on Event Hub. If we are talking about a production environment in a company, the point is we need the data from our production environment to be at some moment sent to Event Hub as well. The production application doesn't need to care much about this. It just gets the data sent to Event Hub and don't care anymore about it. It is the task of Event Hub to handle the arriving data and send this data to the correct layers, which will save this data in history environment. This is the batch layer. The batch layer will save in a history environment, and the speed layer will show the data in real time. So we need something to save the data inside Event Hub. In my example, my demonstrations, I use a small .NET application to read the information and save the information inside Event Hub. Let me show a bit this application, how this application is. So we have here this application. So I'm using a library provided by Microsoft and using a class called Event Sender. Let me open a tool for, it's here, a tool to make some zoom. So I'm using a class called Event Sender. And the event sender needs to be configured with a connection string to Event Hub, which of course you save in the application configuration, will not leave it here in the code. You'll be saving this in the application configuration files. Okay. Then I have here a method called send streaming, and this basically receives data from the API. In my example is the Meetup API, and use the sender configured here to send the data to Event Hub. And here I used some programming tweaks in relation to this. I created a class called Meetup RSVP to read the data from the Meetup. This class has an event. I set the event to my method. And the event will be called when the new data is arriving from Meetup, and the data will be sent to Event Hub. Let's take a deeper look on this class, Meetup RSVP. Meetup RSVP, I have the URL from Meetup. Again, you would like to save, of course, in configuration files for the application. Okay, so I have the URL, I have an event configured on the class. There is a possibility to cancel reading the data, and the main method of this class creates a web request e starts an asynchronous begin get response and process the response inside this begin get response. Every time some kind of response starts, it processes the response. Some kind of response arrives, it processes this response. So it will get and finish with the end get response and response string. While not end of string and not requested to stop, it will continue reading line. The point is, in real-time streaming, like the ones provided by Meetup, by Twitter, and by other companies, this never finishes. That's why we need to create a canceling possibility. Is this stop? Because this would never finish. We'll continue reading data, and we would never reach the end of the streaming. Then we call the event. The event is been calling with the data. That's where it arrives here on the sender streaming and sends the data to the Meetup. Small application making this example. You can make this application more reliable, more trustworthy by deploying it to web jobs on Azure or to durable Azure functions, for example, or NFS. You choose how you would like to deploy an application like this. And this is if you need to. I need to in this example because I'm reading an existing streaming. An existing streaming and sending the data to Event Hub. So I need to connect both. But there is the possibility, if you are working on the business applications of your company, that your business application will send the data directly to Event Hub. So you may not have the trouble to create these, what we would call these middlemen. We need this middleman if we have an existing streaming and you need to send the data from the existing streaming to Event Hub. In this case, we need this middleman. But if you are building a new business application on your company, there is the possibility that you will send the data to Event Hub without using this middleman, like we could call it. Okay, I will not show the execution yet. Let's talk a bit more about the configuration of the environment. And now let's talk about the string analytics. What comes after the Event Hub? String analytics will read the data from Event Hub, process the data, summarizing the data according to some rules that we will specify, and then send the data to the destination. We can specify multiple destinations, different destinations, but in our example, we'll be only sending the data to Power BI. So we are talking about this second step here on the side of the speed layer. So string analytics, and transform what is not needed. What's not needed will be discarded. And this even includes the details of the data. String Analytics will generate a summary and send the summary to Power BI, and you'll see real-time summaries about the data. The details will be discarded. Works based on time window. We'll be receiving data very fast, so we need to manage time windows. How we would like to see the data in real time? There is the time window concept, and we need to plan how we would like to work with these time windows. Sliding, tumbling, hopping, session, or snapshot. We need to make plans for that. And the String Analytics uses a query language called String Analytics Query Language. Oh, yet another language. Yes, another language. Another query language that you need to learn how to work with. But the good news is this query language is very similar to TCP. It is the same. But the String Analytics query language is similar to the SQL, but has additional keywords. And the additional keywords are especially used to handle time for the events and window-based work to handle the time windows for summarizing the event. So you see here an example of the String Analytics query language. We see we are getting data and summarizing. So we have a group by of the data, summarizing the data. We define the input from meetup and define which field contains the timestamp. And we define the output, the destination of the information. So this is a String Analytics job, how it's called, a String Analytics job. We start this job, we build this job with a query, you start this job, and it will keep getting the data from Event Hub. The source is Event Hub, input Event Hub, and sending the data into Power BI. And you see here some different details about the query language, like the definition from window. This query is defining a tumbling window. So what are the types of windows? Tumbling window is a window with no overlapping blocks of time. So this is a tumbling window. So how a tumbling window works? 10 seconds tumbling window. So this creates aggregations of 10 seconds of time, aggregating data in 10 seconds of time with no overlapping over the windows. There are some kinds of windows which allow some overlapping. And windows which allow some overlapping, they may show the same, may include the same record in two different windows. This happens. But the point is, this is not important because you are showing the real-time data. The window that you choose is what real-time data you are showing. In this example, the last 10 seconds in fixed windows. Fixed windows with no overlapping. This is a window example. Let's see other windows. Hopping windows. Block of overlapping time. So these windows have overlap with a small time jump between them. So every 5 seconds, run the query again, create a new window, which will give the count of, this example is with tweets, the count of tweets, so size is 10 seconds, and it will jump on 5 to 5 seconds. It means this window has records which already appeared on the previous window. The 4 and 6 record already appeared on the previous window. But what's important and how it will be displayed in relation to real-time data, it will show that, oh, the last 10 seconds had this amount of records. That will be what will be displayed, and that will be the result in relation to real-time data, real-time analysis. The last 10 seconds had these records. And on every 5 seconds, the window will be updated with the records from the last 10, with the total of records from the last 10 seconds. Sliding window, blocks of overlapping time. Again, we have a window sliding, also is an overlapping window, which jumps according to event arrival. So according the events arrive on Stream Analytics, the window is processed again and again and again. So there is no specific time jump between one window and another. If the events are, let's say, quiet, so the time jump may be bigger. If the events are coming in a huge flow, you get additional data. See, an empty space, like when the events are quiet, are not included, are not emitted. But when an event arrives, the record 8 arrived. Oh, great, record 8 arrived. So, show the information from the last 10 seconds. Show the information about this from the last 10 seconds. And this is making a group by topic and the sliding window on 10 seconds. So it's an overlapping window, so the topics can be repeated and you'll be showing the information from the last 10 seconds according to the arrival of data. Session. Create time windows separated by blocks with no data. What this means? You may have some moments when there is no data arriving. So these moments with no data arriving breaks a time window. So the time window are aggregated on the blocks of time which had data and separated by blocks of time with no data. It's like a timeout. Uh, a timeout of 5 seconds. So if there is 5 seconds with no data, breaks the window breaks here and starts a new one. And the maximum size of the window is 10 seconds. Even if the data is continually arriving, the maximum size is 10 seconds. Then we'll have another window. So there may be a space of time with no data included. It can happen on the session window. And the snapshot is based on a specific timestamp. So it will get data from a specific timestamp. There is no snapshot keyword in this case. We group the data by one specific timestamp, getting the grouping of the data which arrive at that same specific time. Grouping the data by one specific time. This is considered a snapshot window. So we make this using Stream Analytics and then we send the data to Power BI. Let's see a bit how this is configured. On Azure. So it's not exactly this window. So here I have the event hub. My event hub is configured here. And let me show that I have one resource group on Azure called Streaming Demonstration. And inside this resource group, I have an event hub here. And I have a Stream Analytics job. So an event hub and an Stream Analytics job. Let's see the event hub first. I explained that the event hub is in fact an event hub namespace with multiple event hubs inside it. In my example, I created one single event hub inside the event hub namespace. So we have here this single event hub inside the event hub namespace. No recent data infected. Okay. We can configure consumer groups, configure the processing of the data, creating jobs in Stream Analytics, capture the data to storage, how this can be done on the Event Hub. This is how our Event Hub looks like. Then let's take a look on the Stream Analytics job. So I have a Stream Analytics job. Is started at the moment. Although no data arriving, it started at the moment. And then on the Stream Analytics job, I have on the Event Analytics job, I have the inputs, the query, and the outputs. Input, query, and output. So here we are defining what the job will do, basically. The input is a link with the Event Hub. So the Stream Analytics job gets the data from Event Hub. It's configured to get the data from Event Hub. The query is what I illustrated on the PowerPoint. The query are grouping the data, getting the data from the input and sending the data to the output. And the output is a streaming data set, which is defined in Power BI. Is testing the output, the connection to the output is okay. And this is a streaming data set in Power BI. In fact, this is this data set in Power BI. Let me show an example that about creating this streaming data set. Let's talk specifically about this streaming data set. A streaming data set is basically used to receive data and can be used for real-time streaming. One of the biggest use is for real-time streaming. And when we start to create a streaming data set in Power BI, we have these three options. API is an option in relation to the streaming data set. To create a streaming data set and open an API, which will allow us to input data inside this streaming dataset. An streaming dataset basically allows us to input the data. So our application can input the data inside the streaming dataset. In fact, that's what Stream Analytics is doing. Stream Analytics is inputting the data inside the streaming dataset. However, to make this link between Stream Analytics and Power BI, we need to choose the option Azure Stream, and it only explains to us that this configuration is not done in Power BI. We don't configure this in Power BI. We configure this in Stream Analytics. Inside the Stream Analytics, we create the output pointing to Power BI. We set the name of the dataset, the name of the table inside the dataset, and the dataset and the table inside the dataset will be created for us. So Stream Analytics comes to inside Power BI and make the creation of the streaming dataset. PubNub is a service, is an online service which deals with the streaming API. We can link a PubNub service, a PubNub streaming API, with the streaming dataset. That's a different service. I will not go deeper about this. So, on this Analytics job, we can see our Power BI dataset and as the output, the input as the event hub, and the query. Aggregating the data and sending the data to the Power BI dataset, making the aggregation of the data and sending the data to the Power BI dataset. Okay, that's the idea. Let's talk some more details about streaming datasets in Power BI. It can be an API to receive streaming. Basically, it allows the datasets to receive data. It's a destination with Streaming Analytics. So Streaming Analytics can define streaming datasets as the destination of the data. And the data arrives aggregated because the Stream Analytics is the responsible for aggregating the data. The data arrives in Power BI already summarized, already aggregated by Stream Analytics. And then we work over the data that we are receiving from Stream Analytics to build real-time dashboards. Limitations and possibilities. The Power BI needs to be on the same tenant as the Stream Analytics. The Stream Analytics will not work well with Power BI in a different tenant. The Power BI needs to be on the same tenant. We can use Managed Identity Authentication. What this means? This means that Stream Analytics can have an identity inside Azure, and this identity will get permission on the dataset in Power BI because they are in the same tenant. The Stream Analytics and the streaming dataset stays on the same tenant. So I can illustrate this by showing the managed permissions here and showing that there is here a permission set to a service principal. It doesn't immediately show the name of the service principal, but basically is the identity of this meetup job. Principal name, meetup job, is a system assigned identity. If I try to add a user, if I type meetup, it is complaining about some duplication. I may have added this user in different places or something. It's complaining about some duplications. That's why it's not immediately showing the meetup job here. I have a second streaming demonstration. Let me see, the second one is also showing service principal. But the idea is, sorry that I haven't double checked this part of the permission, but the idea is you will see the user, this meetup user, this meetup job user, you see inside the Power BI, and you'll be able to give this guy permissions in Power BI. You'll be able to give permission to this meetup user inside Power BI. That's the basic idea. And one stream analytics job can generate one single data set and one single table inside this data set. We could consider this as a limitation. It's not a usual limitation for stream analytics. In other, let's say, regular situations, stream analytics could send the data to multiple destinations. But their Power BI API requires that stream analytics generate one single dataset and put one single table inside this dataset. One job generates one dataset and one table inside this dataset, and that's it. That's it. No additional tables or something like that. There are other technologies to use as an alternative to these limitations. If for some reason these limitations don't work for you, Power BI has another streaming technology, which is the streaming data flows. The streaming data flows can be used, and they have different limitations. They don't have the same limitations than the streaming datasets. They have all the are used in different scenarios. So streaming datasets in the streaming data flows in Power BI can be used in different scenarios. But on this session, we'll focus only on the streaming datasets. We're talking basically on the about the streaming datasets, and here we are talking about the creation options that I just illustrated a few minutes ago in relation to the streaming datasets, the options to create a streaming dataset, and how to tie existing streamings with Event Hub. Basically, the Event Hub will send the data to Stream Analytics. The Event Hub will be the input for the Stream Analytics job, and the Stream Analytics job can send the data to Power BI. Each Stream Analytics job will be generating a dataset with a single table inside Power BI, which will receive the real-time data. So, a demonstration about the streaming dataset. Let me show another piece of the recording. Just a moment, let me locate the correct point of this recording. I explained it before, I cannot execute the streaming application because the meetup link doesn't exist anymore. I'm very sorry for that. So as a workaround, I'm showing a previous recorded video about this.
Hello, Dennis. Your voice is not audible.
Sorry?
Voice is not audible.
Do you know what I need to configure here for the audience to hear the audio? Hello?
No. Hello?
Yes. Do you know what I need to configure for the audience to hear the audio?
You can explain. You can play the
Okay.
video and you can explain in between.
Okay, basically this video is showing the demonstration about the streaming dataset, showing how it's configured with the managed identity. The dataset name and the table name. And the dashboard created from the streaming dataset. Now, there is a very important reason for creating dashboards, for using this dashboard with the streaming dataset. The important reason to be using dashboards with the streaming dataset is because the dashboard they are refreshed automatically when used to gather the streaming dataset. When used to gather the streaming dataset, the dashboard are refreshed automatically. The reports, they are not. There is a feature on the reports to make a page refresh. To make a page refresh every 10 seconds, every 5 seconds, this is configured. But this doesn't work with the streaming dataset. Why it doesn't work with the streaming dataset? Because the connection from the report to the streaming dataset is always what is called a live connection. The type of connection between the report and the dataset is a live connection. It could be a direct query connection, it could be an import connection, but it is a live connection. And this kind of connection doesn't work with the automatic refresh of report pages. So if you build a report over the streaming dataset, we need to keep refreshing the pages. Every time we refresh the report page, we'll see a new information, but do not have the automatic refresh. The dashboard, on the other hand, will have the automatic refresh. According to the information arrived, the data will be refreshed. And this is one of the last points here about the rules and limitations. The connection from the report to the dataset is always live connection. The dataset cannot be used in a composite model. I can't get the real-time data and mix with another model. Don't support page refresh configuration because the live connection. The live connection doesn't support the page refresh configuration. Then additional details about the Power BI user interface are basically this, what I'm talking about, the dashboards. The dashboards make the refresh automatically. Report pages need to be configured to have this automatic refresh. The configuration is possible, but not with the streaming dataset. With the streaming dataset, this configuration is not accepted. It's not only a report page configuration. If we decide to configure this for any other reason, it would need to be configured in the portal as well. The Power BI admin portal needs to allow this kind of automatic refresh, defines the minimum rate that will be acceptable on a tenant level for that Power BI tenant. And then the users will be able to create this kind of automatic refresh, but it's not supported for streaming data sets. It is supported for streaming data flows, but this is a different thing, another different option. Okay, so that's it for today. We talked about the streaming datasets. I think there are some questions on the chat. Let me take a look.
Yeah.
Daniela Mato is asking, is there any direct application for the identity authentications like OTP one-time pair? For example, could you explain better what you mean, Danielle? Because I'm not sure if you understand. Once you set the string analytics with the managed identity, the system managed identity, and you give permission to this system managed identity on the Power BI dataset, you don't need to care about password, for example, one-time password, something like that. You don't need to care about it. So I'm not much sure about what you mean. Could you explain better about this question? Is there any additional question about the subject?
So let me share the screen and announce the key takeaway.
Okay.
So participants, I'm going to announce the key takeaway. So we are going to provide free certificate, participation certificate for all the participants. And already I have shared the link to claim the certificate. This is a link. So just let me share the link, and you can provide your name, email, and your phone number, and you can click register. Again, there is some. Yeah, yeah, will be taken to the dashboard. So now you can click claim certificate, claim certificate. Yeah, it will be asking your name, again your email ID, and you have to click next. Now you can provide the secret code, which will be provided in the which will be provided by me now. You can provide the secret code and you can download the certificate. Now the secret code is IKX1F4. Again, I repeat the secret code IKX1F4. So again, I will put the secret code in the chart. So secret code is available in the chart, so you can download the certificate. So audience, any more questions?
I can see on the chat Danielle provided additional information about the question. She's saying that she would like to set up a system with a password between Stream Analytics and Power BI. Is this possible? Basically, no, it's not. Basically, it's not. Not with streaming data sets, but if you use the other technology, streaming data flow, uh, you wouldn't need a password, but the streaming data flows work in the opposite direction. What do I mean with that? I mean that using streaming data sets, it's Azure who puts the information inside Power BI using streaming data flow. It's Power BI who goes to Azure to get the information. And in this case, you will not use a password, but you use a key directly to Event Hub, and Power BI will get the information there. Then you will not need to use the manage identity like I explained it. And this will allow you to be in different tenants, but it's not possible with the streaming data sets, only streaming data flows. Okay, and I see there is a raised hand. Vic has, do you have a question?
Participants, any questions? So some question is there, Dennis?
About Databricks.
Databricks.
Yeah, I'm seeing the question about Databricks. We can do real-time streaming that can be consumed by Power BI. So why using two services, Event Hub and the Streaming Analytics, and instead of Databricks? First, I cannot provide you a perfect answer about that. I would need to research a bit about that. But I'm not completely sure about what you're talking, that the two services, Event Hub and Stream Analytics, would cost more. I'm not so sure about that they would really cost more. And besides that, Event Hub is a service in Azure that is intended to receive a heavy flow of data. Databricks is more intended to process the data. If I understand what you are saying that you can do with Databricks, you can process the data, and with the data that you are processing, you are getting from somewhere, maybe from a data source or from a storage, you generate a string for Power BI, for example. You could generate a consumption point for Power BI. But it's not like Event Hub. It's not intended to be like Event Hub, who is open to receive data from many different sources that will be sending data in high volume, high speed to Event Hub. So the Event Hub is focused on that. This is the focus uh, to receive a huge amount of data. That's why in relation to Azure, Event Hub is always the first technology to be inserted in the scenario of a Lambda architecture. Event Hub is the first piece to be inserted in a Lambda architecture. I cannot tell you the full difference from these two Databricks, but let's say that my answer at the moment is an educated guess about what would be the difference. The Databricks, you are processing an existing data source, and providing the data to Power BI. The Event Hub is open to receive huge amounts of data, and then this data would be summarized and be sent to Power BI. There is a small difference in this point on how the Event Hub is more open to receive a high flow of data. Okay, there was another question from Danielle. I think Danielle had the raised hand, but not anymore. I hope the explanation helped. Anyway, I can leave my email on the contacts, and if you like to talk more about this difference in relation to data
Dennis,
bricks.
Dennis, am I audible?
Sorry?
Am I audible?
Yes.
Just, I mean, I myself asked the question about the Databricks. What I am trying to say that with Databricks, yeah, definitely Event Hub and Databricks is not same. But in Databricks also I can do real-time data process. My question is little bit more context to the cost. I mean, if the data volume is not that high, but in Event Hub and Azure Stream Analytics, I am using two Azure service. And compared to that, if I have done my analysis, that Databricks auto clustering, auto termination feature, definitely one service, and Azure Database is the first class service in Azure. It would definitely benefit a lot in terms of the cost and achieving the same thing. So that is what I'm just putting. I mean, it's not the question, I'm just clarifying with you. Is that clear now?
A bit, more or less. We can talk more. If you would like to send me some message by mail, we can talk more by mail. But I would say, you mentioned something about the storage, the Databricks processing the data on a storage. But the point would be, how the data arrives to the storage?
No, it is not storage. I mean, Power BI can directly connect with the Databricks cluster. So the real-time
And
streaming
where
data.
the Databricks cluster will get the data?
Databricks cluster will be using the read stream of the PySpark and get the data from your source application, right? They can consume the source application. I mean, just a thought, because stream analytics is very costly.
Yes, but this is a different solution. This is not exactly a solution for real-time data with Databricks. It's not intended to be so. The solution for real-time data is using Event Hub. If you want to not use string analytics, okay, there is another option. If you use Power BI data flows, you avoid the string analytics if you don't want to pay for the string analytics. Power BI data flows can be used and you avoid the string analytics. Okay, that's an option. But if you're talking about ingestion of data, Event Hub is the technology to go for it. If you build a solution to using Databricks, and the Databricks needs to go to your data source to get the data, you are not really receiving ingestion. This is not really an ingestion solution. It may achieve some solution that is okay. It's enough for you, but may not be a so good ingestion solution. That's the point. That's the difference. Okay,
Any
we
more
can
audience?
we
Any
can
more? Yeah.
we
Any more?
can dig deeper on this. I was to mention that we can dig deeper on this. Um, through email, anyone who would like to contact me, feel free to contact me. We can dig deeper on this through email. Not a problem. My answers now about Databricks are not so deep because I'm not a Databricks specialist, but I could help you to get a more precise answer about that. But This is considered an important point. I mean, Databricks is intended to process the data, but it will need to go to the data source. It's not exactly an ingestion process. If you really need to ingest a big volume of data, you need Event Hub.
Okay, any more questions? Okay, shall we wind up? Dennis,
Yes?
shall we wind up?
Yes.
Yes.
Okay, we can conclude for today.
Yeah, okay.
Thank you everyone for attending the session. I hope you enjoyed the session and feel free to contact me at any time, any of my contacts.
Yeah, that's an excellent session on how to ingest the data by using Event Hub and how to create a business insight by using Power BI. So on behalf of Multicloud for you, we'd like to thank our speaker of the day, that is Dennis. Again, once again, we'd like to thank you. Thank you. Thank you, participants, for actively participating in the session. Thank you.
Thank you very much. See you. Everyone had a great evening, a great end of weekend.